Hi, my name is Doug Natelson and I'm a physics professor. I'm the chair of the Department of Physics and Astronomy at Rice University down here in Houston, Texas, and this is my lab. I have a research group of undergrad and graduate students who study the electronic, magnetic, and optical properties of materials and how these change as the materials get down to the atomic scale. This discipline is called solid-state physics or condensed matter physics, and while it might not be as flashy as particle accelerators, we do get to play with cool tools like lasers and electron microscopes, and I guarantee solid-state physics has had more impact on you in your everyday life than any other branch of physics. Understanding this stuff has made it possible to have things like, well, basically all of modern electronics and communication technology, silicon chips, cell phones, magnetic data storage, the lasers and fiber optic communications technology that support the internet, the CCD camera on this phone that's recording this video, the superconducting magnets in MRI machines, all of those things exist because people did solid-state physics to figure out the rules that the world obeys. Scientific research is puzzle solving. We have limited tools. There are some things that we know how to make and some things that we know how to measure very well. And with those constraints, we're trying to figure out the rules of the game, how the universe works. Sometimes we can write those rules in a very compact way, like F equals ma, or E equals mc squared. Often it's more complicated, but the language is always the same, mathematics. Engineering is when you take those rules and you use them to solve particular problems, like how to make electricity out of sunlight, or how to detect thunderstorms coming from 100 miles away. The boundary between science and engineering is blurry, but the relationship is one of mutual benefit. Lots of science majors become engineers, and vice versa. Elon Musk, founder of Tesla and SpaceX, was an undergraduate physics major. So why is it important for us to study physics? 3 main reasons. First, there are still a lot of things we don't know or understand within the realm of physics. Understanding isn't always of instant benefit to society, but if there's one thing that we've seen in the last couple of 100 years, it's that scientific knowledge often comes in handy in ways we could never have anticipated. Science works as a way of figuring things out, and physics, next to math, is the most foundational of the sciences, trying to get at the basic underpinnings of reality. Second, there is something deep and important about trying to understand the world. It's just my personal take, but I think it's an intrinsic sign of human progress that we know a heck of a lot more now about the universe and our place in it than we used to. Knowledge is power and ignorance is not strength. Don't you want to know how things work? Third, it's fun, and it teaches us how to think logically and critically and quantitatively. Always test your ideas. How can you distinguish between possible explanations? Measurements, the response of reality to your tests, are the final arbiters, not what you hope or want to be true. There's a reason that many fields, from economics to computer science to cancer biology, are populated by people who have been trained in physics in the first place. So good luck on your studies, and remember, it might seem like there's a long way from a block sliding down an inclined plane to particle accelerators and superconductivity, and homework sets may be annoying, but it is physics that's made an awful lot of the modern world possible.